In this video, we're gonna go over the power rule, which is a great shortcut to take derivatives and yeah, just to take derivatives of mainly polynomials, but you can also use them for a few rational functions. So what the power rule says is that given any polynomial which is in the form x of n, x to n, the power, so the derivative of that would be, so d over dx is the derivative, and our function is x to the n, where n can be any number, so just any constant. And the derivative of that function would be n times x to the n minus 1. So with that in mind, let's look at a few examples. So let's try taking the derivative of a function like x cubed. So in this case, n equals 3. So that would mean 3 times x to the 3 minus 1 power, which gives us an answer of 3x squared. Let's do another one. d dx of, let's say, 2x to the fifth. So in this case, n is 5, right? So we bring 5 out to the front. So 5 times 2x to the n minus 1. So 5 minus 1 equals 10x to the fourth. Let's do a few more of these standard polynomials. So 2x squared minus 3x cubed. Now, even though this is a binomial as opposed to a monomial, you still do the same thing, except you take the derivative of each term and then subtract them together. So let's do the first term, 2x squared. So you bring the 2 out to the front. 2 times 2 is 4. X to the 2 minus 1 power. And now for the second term. You bring the 3 out to the front. So 3 times 3 is 9. X to 3 minus 1 power, which will give us 4x minus 9x squared. Pretty simple. And once you get the hang of this, you honestly don't even need to write it down to solve it. You'll be solving it in your mind. Let's do a few more. 2x squared again minus 15x to the fourth plus 20x minus 5 over 2. So let's go through it step by step by focusing on one term at a time. So 2x squared, bring the 2 out to the front. 2 times 2 is 4, and then we get 4x to the n minus 1, so 2 minus 1. Let's go to the second term. Same thing. Bring the 4 out to the front. 4 times 15 gives us 60. And 4 minus 1, which will be 3. But let's just leave it at that for now. Same thing here. So x is another form of saying x to the first power. So we can do 20 times 1, so that just remains 20, times x to the 1 minus 1 power. And then finally for our last term. So as we can see, there's no x here, so we can assume that it's x to the 0 power, which is 1, right? So minus 5 halves times 0 times x to the 0 minus 1. Now let's evaluate all of this together. So 4x to the 2 minus 1, that's just 4x, minus 60x to the 4 minus 1 is just 60x cubed, plus 20x to the 1 minus 1 is x to the 0, which is 1. So that just remains as 20. And here, we have a 0 here, so the entire thing cancels out to be 0. So at the end, this is our final derivative using the power rule. And using this rule, we can remember two tips: that any constant, any constant's derivative will be 0 because there is always an x to the 0 term, which will end up multiplying the entire equation by 0. So any constant's derivative is 0. We'll just say d dx for derivative equals 0. And 2, any x term, x to the first term, just loses the x. So, for example, if it's 20x, it loses the x and becomes 20. If it's 4x, it loses the x and becomes 4, and so on and so forth. So these are two good tips to remember when using power rule for polynomials because they make a lot of stuff easier. For example, we wouldn't have needed to done all of this if we just knew that phi halves was a constant, so the derivative of a constant is always 0. Okay, so let's look at power rule with rational functions and square root functions and cubic functions and so on. So say, first I'm just gonna write the power rule formula for reference up top. So d dx of d dx of x to the n equals nx to the n minus 1. So let's just have that up there for reference. And let's use a few rational examples. So let's say we have the function 2 over x cubed, and we want to find the derivative of that. So to find the derivative, we can use the power rule actually. So if you remember that you can move any x term up to the top of a fraction by making their exponent negative. So this is the same thing as 2x to the negative 3, which is pretty much a polynomial. And so now we can use the power rule. So now we can conclude that the derivative of 2x to the negative 3 equals, bring the negative 3 up to the front, so negative 3 times 2 times x to the negative 3 minus 1. So that'll leave us with an answer of negative 6 times x to the negative 4th, or in rational form, negative 6 over x to the 4th. And that's our final answer. You can use this with pretty much any monomial rational function. So let's try it with another one. So let's get some bigger number. So negative 6 over x to the 4th. Oh, whoops, I just rewrote the answer. Let's try negative 7 over x cubed. Actually, let's make that x squared. Okay, so let's do the same thing. Let's bring the exponent up top, which will give us negative 7 x to the negative second power. And then we can take the derivative using the power rule. So let me write it all down first. We bring the negative 2 up to the front. So negative 2 times negative 7 times x to the negative 2 minus 1. Remember, in this case, n is equal to negative 2. So that gives us 14x to the negative third power, which we can simplify in rational form to be 14 over x cubed. Let's go over a few more examples. So let's have the function 24 over x squared minus 3x cubed plus 4x minus 1. Now, that's a pretty big function, but if you remember, start by taking the derivative of each term individually. So let's rewrite this function in by making this a polynomial, so it'll be in a somewhat more polynomial form. 24x to the negative second minus 3x cubed plus 4x minus 1. And now we can take the derivative using the power rule. So d dx of this entire thing which will give us, let's take the first term, so negative 2 up front, x to the negative 2 minus 1 minus 3 times 3. Remember, we're just moving the negative 3 up front. Sorry, not negative 3, the positive 3. And x to the 3 minus 1, which is 2. And now let's take this term. So from our derivative rules before, we can remember that any x to the first term just loses the x. But for the sake of practice, let's write it out fully. So 1, because this is a 1 here, times 4x to the 1 minus 1. And finally, a minus 1 here. Now we can remember that any constant's derivative is 0, but we can also evaluate it out. So since we have an imaginary, not imaginary, a hidden x to the 0, over here we'll have 0 times 1 times x to the 0 minus 1. And let's evaluate all that out. So negative 48 from the 24 times negative 2, x to the negative 3 minus 9x squared plus 4 minus 0, which gives us a final answer of negative 48, moving the x cubed term to the bottom, minus 9x squared plus 4. And that's the derivative of this equation. So to use the power rule for functions with cube roots with the next term or square roots with the next term, it's pretty much the same principle as the as rational functions, right? So you want to rewrite them in a way so that you have an exponent on the x term. So let's again write the power rule up top for reference. So we have d dx of any function x to the n. Great. So let's begin. So let's say we have the function square root of 2x, and we want to take the derivative of that. So we can rewrite this function as the square root of 2 times the square root of x. And we know that taking anything by square root is basically the same thing as raising it to the 1/2 power. So this becomes the square root of 2 times x to the 1/2. Now see how we can use the power rule here, because this is our n and this is our x term. and this is our coefficient. So let's try that, shall we? So we have d dx of square root of x to the 1/2 equals, so let's take our 1/2 and put it up front. So 1/2 times the square root of 2 times x to the 1/2 minus 1. So that gives us root 2 over 2. We're multiplying the 1/2 times the root 2 times x to the negative 1/2. And since this is negative, we can move this to the bottom of our fraction, giving us root 2 over 2 over 2x to the 1/2, which simplified into square root form gives us root 2 over 2 root x. And that is our final derivative. Let's go over a few more examples. So let's have the derivative of 3x squared minus 4x plus square root of x cubed. Yeah, x cubed. Actually, no, let's make that the cube root of x squared minus 2x to the negative second power plus 5 at the end. So let's begin by taking each term individually. So the first term, so move the 2 out to the front, becoming 6x, 2 minus 1, so that's just a 1, minus, so that's a 1 here. So move this out to the front, keeping it the same, and x to the 1 minus 1, so x to the 0, which leaves it at a 4. Plus, now let's convert this into the power rule form. So it's basically saying x to the squared, and we want to take the cube root of that, so we're basically raising it to the 1/3 power. Using a few exponent rules, we can simplify that further into x to the 2/3. So x to the 2/3, taking the derivative of that will give us 2/3, because we moved the 2/3 out front, times x to the 2/3 minus 1. And in fraction form, we can just write that as 3/3. So 2/3 x, and 2/3 minus 3/3 will give us a negative 1/3. Minus 2x to the negative 2. It's already in the correct form to take the power rule, so we don't need to change it. So we move the negative 2 up front, so making this a positive. Negative 2 times negative 2 is 4. 4x to the negative 3, because again, negative 2 minus 1. And remember that the constant, any derivative of it is always going to be 0. Plus 5. Sorry, not plus 5, plus 0. So now let's simplify this even further. So 6x minus 4 plus, now since it's a negative exponent, we can move that to the bottom. 2 over 3 cube root of x. All we're doing is converting the exponent form to square root form, or cube root form in this case, plus 4, and let's move this x term to the bottom as well, giving us 4 over x cubed, which will be our final derivative. Let's do one last example. Let's have 2 root 5x. Great. So again, let's convert it into a form that makes it obvious to use the power rule. So 2 times the square root of 5 times the square root of x equals 2 root 5 times x to the 1/2, because square root is basically raising something to the 1/2 power. And now let's take the derivative of that. So d dx of 2 root 5 x to the 1/2 equals 1/2, because we're bringing it out front, times 2 times the square root of 5 times x to the 1/2 minus 1. So 1/2 times 2 give us 1. So now we get the square root of 5 times x to the negative 1/2, which, simplifying further, because we're going to move this term to the bottom, will give us the square root of 5 over the square root of x. We're just converting it back into square root form. And since we're dividing two square roots, we can envelop them under one whole square root. So our final function could be the square root of 5 over x.